hopefully the two puppies that I got are going to behave and they don't knock over my tripod or anything like that. I don't always show my brokenness or my messiness or all that stuff. I like to make things look a little nice, but yeah, had to leave work a little early at 2 in the morning instead of 6 because I had a crazy fever that I had to take care of by letting it sort of just pass. So there's that too. So anyway, I was trying to get uh, maybe an interview or something about talking about decentralization. Again, I've made videos and done live streams about it. So I do want to make another one, but just try to make things simple, sort of dumb it down to sort of pretend that we're like children for a second here. Because we got to actually think about what do we mean by decentralization, but then we also have to think about what's actually going on. The important thing I think a lot of people miss is that the double spend checking part of Bitcoin makes it different than other things you can do with information and data. And because of that, it changes the dynamics of what's required. So people might not understand this, but this is really how it works. So let's just talk about, so a lot of times we think of centralization as, do we have like this central node maybe that if it were to fail or were to go down, or if somebody were to try to control it, um, that could be a problem. So it's a central point of control or central point of failure, something like that. Now, I want to be more specific in the definitions of these little nodes, right? Because these nodes are just abstract ideas. They could represent anything. So you could think of it like this. So you could say, well, which one is more decentralized? You could say we have one node over here, okay? And then in our other hypothetical universe, we have two nodes. Now, I'm not going to draw them as connected because we're going to assume that a connection means we're going to say that that means a consistent connection. But if it's not connected, that means it's like an optional or a transient connection. So if they happen to run into each other, if they happen to want to connect with each other, they can. Otherwise, they're just disconnected. So you have two copies here of data. So if you have a video or you have a file, an invention, you have contract or something like that, say your will. Okay, if you have one copy of it somewhere, that safe burns up, you're going to lose it. If you have two copies, well, then if you lose one of them, you still have the other one. So we might say that this side is the more centralized side, and this side is the more decentralized side. We're going to say decentralization probably is better, although that's an assumption because it depends on what you're talking about as to why you're going to argue that it's better. So we already have this idea that decentralization seems to mean more nodes. But, and there's a lot of people that say BSV is centralized and BTC is decentralized. And it's true that you kind of push BTC to have more nodes by using small blocks. But there's another idea about decentralization, and that has to do with the connections. So let's go ahead and move on from this, and we're going to talk about connections. So having more nodes might mean more decentralized to you. But let's say over here you have 5 nodes. Okay, over here you have 4 nodes. Okay, so you might say this one has more nodes, so it's more decentralized. But let's say we're talking about a network that needs to stay connected all the time. Okay, so let's say this one is connected like this. Okay, now let's say this one is connected like this. Okay, if I sever one of these, the network is still connected. Okay, whereas if I sever one of these, the network is disconnected. And notice how both of those have 4 connections. This one actually has more nodes. But notice how if you don't have as many connections as there are nodes, you don't have that connection. Now, let's say I could even have more connections. Okay, now in order to separate this network successfully or efficiently, I'd have to sever 3 of these connections if I'm talking about connections. And here I could remove, okay, so here I could remove any node that I want. The network is still connected. But here, let's say I remove this node. Well, now the network is disconnected. Okay, so now we have these ideas that come from graph theory that have to do with a min cut. Okay, so what's a min cut? It's basically going to be how many edges do you have to remove from your network to sever it. Okay, it could also involve when you're talking about decentralization, removing a node. Okay, because you could have a well-connected network up here and a well-connected network down here. But if they're not connected to each other, if they're more than just this one edge, well, you have an easy cut right here. You also could say that you could remove this node. It would also sever the network. Okay. So more nodes doesn't necessarily mean that you have the quality, the property of having a network that is dependably connected to itself. Okay, so let's bring that all in. And we're going to talk about Bitcoin. See, because Bitcoin is a little confusing to talk about if you don't know the difference between what a wallet should be and what a node should be. So I want to draw wallets like they are these little disconnected dots here. Okay. If they want to, sometimes they can connect with each other. But whether or not that connection is stable shouldn't really matter, because it should only have to do with that wallet doing a transaction with the person they're interfacing with. So it's up to them to decide that they're going to communicate with each other. And if they can't, well, it's already going to be difficult for them to be doing business with each other anyway. And it won't affect somebody else. We'll say it doesn't really affect somebody else's ability to use the network, because as long as they can do what they need to do, it shouldn't really depend on some other pair of wallets connecting. Okay. So if you want to double spend check, you're going to have to take all the information from the network. Okay. This is not something that you'll get if you have somebody with a wallet here who pays someone here. They can check it because they can see that the signature is valid. They can see that it's based in a Coinbase if they have that downloaded as a previous history. They could probably also use the proof of work amount, like the level. So even if they haven't updated for a while, they could see that it's a valid transaction that's likely not that's been accepted by nodes in the past by a certain amount of time, even after the recipient has connected to the internet, because they can see the level of proof of work probably as well. That's another thing that you could put in a wallet. So the question is, well, what do you need? What is the actual network then? Okay, because BT Sears will say, hey, we want all these wallets to be miners equally. Um, but the problem with that is that you can't efficiently double spend check now, because you have to connect to the internet. You have to download all the recent the most recent blocks and the most recent transactions all the time continually to make sure that that transaction is not being double spent. So they can't really trust the system. Well, they have to wait for some blocks to be produced. Now, if you have a bigger, say a bigger node, not a wallet, but a node, okay. Now these nodes are going to have big connections between each other, okay. And I'm going to draw them big because they're going to be more like airports than they're going to be like residential homes. And they're going to be able to handle all the throughput of all the transactions going on. Okay. Now, to control these, once I start adding a few more till you get like 1,000, you're going to have about that many squared number of connections. So instead of 1,000 connections, you're going to have like 1,000,000 for 1,000 nodes. So I'm going to draw these. These are big connections, and these are continuous connections. They don't stop, okay? They keep going all the time. So now this wallet, let's say this is the recipient wallet. This wallet can communicate with this node right here, and it can double check, hey, is this transaction a double spend or not? It checks, and this node, when it's producing blocks, it's not like Caspa where it can produce a block that technically has a transaction in it that's going to get rejected because it's going to have a double spend, and there's another block, right? So you have to depend on the ghost DAG. Okay, but here he doesn't have to wait for the ghost DAG. He can actually trust what this node is going to say about, hey, I accepted this transaction, because this node is economically, it's going to lose a lot of money if it tries to accept transactions that and put them in a block that the other nodes are not going to accept. It's going to lose out. So these other nodes, they're all going to be sending the transactions they accept. They're going to say, hey, I accepted A, not B. I accepted C, not D. Whenever they see a double spend, and they'll want to send that information out because they know that nobody's going to be able to build on that block unless they have that transaction to verify so that they can build on it. So the only economic way for them to make money is for that block to go 100 levels deep. If for it to go 100 levels deep, it's got to be built on by the rest of the network. So unless the rest of the network says, yeah, I can build on that block, they're not going to make any money. Okay. So BSV is the original Bitcoin is very strong incentive for these nodes to get you a response that's going to tell you that whether it's really should be the double spend or not. It's whether it's going to be the one that's accepted or not. And that's it. I mean, that's the thing. The double spend is the main core issue. If you didn't need to do the double spend check, you may not really need. The only other reason to have nodes would essentially be like storage, I think. But if you have wallets that are chains of signatures, you wouldn't really need storage. And that's why, like, I came up with the idea for a protocol that's a reputation, and it's basically digital word of mouth. And you don't need a blockchain for it because there's no double spend checking. There's just data that has to do with, hey, I did business with it. I signed with this other key that we did business together, and I get to vote by telling everyone else I do business with whether or not that business was good or not, or whether I'm going to download their recommendations and accept them, or if I'm going to ignore them because I think of them as a spammer. Okay. And that way, everyone's a kind of a wallet or an identity, and they don't have to use these nodes. But here you need nodes because with money, you have a quantity that you have to keep track of. So they had the problem called the double spend, where you could try to pay someone somewhere, and then your wallet could lie, and it could say, "Hey, I'm going to spend this money over here," and it was money that you already spent. And if you did that, and it was a permissionless system, that means there's no limit to how many wallets you can make. You could get away with scamming someone. You could get away with buying something, receiving the product quickly before they find out that you spent it somewhere else. And then if the money can just be spent multiple times, it would just multiply, and it would have no value because you could just multiply it all the time. Okay. So there's like a mathematical there's a property with money where that seems to be the only way that you can do it digitally. Uh, as far as like, you still need you need to do double spend checks. And I don't know how to explain why that's seems to be the case for money, but not the reputation, because the reputation, you're downloading information and then you're just, it's all based on word of mouth, basically. It's, you could have 10,000 scammers, and on Amazon or on Facebook, they'll get away with it. They'll rate each other 5 stars. They'll give each other thumbs ups. But if you're using word of mouth, doesn't matter if 10,000 scammers all give each other good ratings, unless you do business with them, or unless you do business with someone who recommends them, and you take that into account, it's not going to affect you. Okay, it's going to be like the future of Google searches. You don't have to ask Google. You can search what you think, how you understand the truth to be. It doesn't mean that there's not an ultimate truth or an absolute truth. It means that nobody can be assigned. You can't have a central authority like Google or Facebook or someone who's going to tell you what the truth has to be. Okay, because if you do, then as soon as they get something wrong, well, then there's no way to correct that. There's no way to fix it, because you're assuming that they're the final authority. Whereas in a decentralized system, you're saying, well, there might be such a thing as absolute truth, but we don't have the authority to define what that is in our network. We have to allow every node in the network to filter things based on their own knowledge. They have to be able to work things out that way, kind of like word of mouth. There's a reason why it works and why it's been around for so long. So you guys can watch my other videos. I gave a video about decentralization. I showed the difference between distributed network and a decentralized network. But really, it's the double spend checking. Okay. So I'm going to put DS, because it's the double spend checking algorithm. I call it an algorithm because I see it as an algorithm that the network is doing. But that's essentially what it's doing, and that's the reason why you have to have big nodes and why you have to have them all ready to connect with each other, because you want a zero conf. Okay, if you don't know what a zero conf is, this is important, foundational to Bitcoin. Zero conf means that you know that a transaction is accepted by the network, even though it's been accepted still in 0 blocks. So it hasn't even showed up in 1 block yet, but you still can be over 99% sure that that transaction is accepted with finality, because you can contact not just one node, okay? Because if you, maybe you can't really trust the node completely, okay? But this guy, he can contact like 2 or 3 nodes. And if he does that, and also even if he contacts one node, but these nodes have their own keys, and he knows his wallet keeps track of the some of these big nodes sort of public keys, their signatures. This node can actually confirm, and I'm not saying this is how it works right now. I'm just saying this is how it could work in theory. This node could actually cryptographically show that the transaction was accepted not just by himself, but by all these other ones. Because you don't have to worry about, you don't have to even worry about, like in an iPhone, if I'm messaging you direct, okay, you could, in theory, they could, they could, they have the man in the middle attack, where they could not only read all your messages, but they could change them for end-to-end encryption, because they would impersonate the public key. But if you already go and verify, if your wallet keeps verifying these public keys and makes sure that it has the correct public key for these nodes, and then at the end, say one point you're in a cave, you're in Mammoth Cave or something, you can only connect to one node, right? For some whatever reason. But you can see that they signed it, they've accepted it. So even by contacting one node, because it can send cryptographically signed information, there's no reason why it can't. It can prove to you, hey, this has literally been accepted by the entire network. They're all tracking, you're good. Your transaction is 100% verified because all the nodes have signed off on it. So unless they're all lying to you, and then they're trying to accept a double spend, which by the way is going to be fraud. So somebody trying to do that, you could. So this is why you could have off-grid vending machines that never need to connect to the internet. I wanted to actually write a patent, or I wanted to like describe how to build one of these things, because you could just make a vending machine in theory that doesn't you could put in a few tricks where it updates information using wallets, or it checks for some proof of work so that it doesn't even have to update, doesn't even have to connect to with the internet like hardly ever. I mean, going from hardly ever to like none, because you could use some tricks and stuff to sort of bypass that. And then if somebody did find a way to try to fraudulently double spend it or whatever, you'd still have that, traced to say like, why are you fraudulently buying these, Pepsis or whatever? Because you can't do that when you go to these vending machines where they have the open refrigerator. You can take what you want physically, but there's cameras on you, so there's still a limitation. Anyway, so what do you guys think as far as the definition of decentralization? Because when you have 1,000 nodes and 1,000,000 connections between them, wouldn't that be harder to cut and sever? Because you'd have to remove, in order to separate the network, okay, I'd have to remove, look, if I remove this, the rest of the network is still connected with each other, okay? Whereas, say I don't have these big nodes, but I have a lot of nodes, right? Millions. Say I have all these wallets, let's say we're running BTC, and they're all nodes, right? Okay. Well, all it takes is some spam, and you can start cybling this network, because what you get is, you get, say you take this guy out, you spam here, Okay, now you have a conflict that has to propagate. If you double spend and you send it here and here, and they don't have a direct connection with each other and they have to propagate, now you have to propagate double spends all over the place. And they have to resolve that conflict. And it's going to be more and more and more expensive. And we already know with BTC, you're not going to get paid a lot with fees for utility because you're limited to a small number of transactions anyway. So it makes sense if you're distributing data, even if you're a YouTube video servers or something. But it doesn't make sense for a double spend check because that basically has to be quick. Even if it's not instant, it has to be useful, it has to be pretty fast because you can't really finalize transactions quickly enough to get your product. So I'm going to check some comments and see what you guys. I want to know if BSV can make humans more free. I mean, if you think money can make people more free, because we're already using it, right? I see your comment, Jonathan. And I got 2 puppies right here. So let's say hi to the puppies before we get off. Hey, puppies. Yeah. All right. So it's been fun, guys. And maybe Crypto Kate will like this video or maybe some of my other videos. I'm not sure. But there we go. Looks like I had to talk for less than half an hour. See you guys later.